Okay, in this video we're going to try and get the enemies class pretty much doing most of what it's supposed to be doing. Alright, as you can see here, I've got the storyboard open here and the enemy class open here. The first thing we're going to need to do is include the enemies class in the storyboard. I'm going to include this inside the create scene after the scene declaration here. The reason for that is usually you'd put these up at the top, but I want this after the scene. That way the enemy's class will have access to the scene. As you'll see shortly, that's quite useful, actually required. Also, you'll notice here that the name of the file is classes .enemy. In this context, the dot is actually the same as a /, so it just means directory. So you're including the classes file, or the enemy file, in the classes directory. I can save that, run that. As you can see here, there's no errors. That means that it's found the class. Alright, if we go to the enemy class, we haven't actually created the class yet. So the first thing we're going to have to do, let's create this. Let's add an image to it first. So we're not going to change this function. As I said, this will be the same for all of them, just changing that name and the meta table. So we're going to any images or attributes we want to add, we're going to add in here. So we're going to need to, well, the first thing we're going to do is we're going to load the image. Alright, you see here I'm saying self.image. Alright, so I'm defining a new variable here, image, which is a member of this instance, this class, this instance. The self here represents the instance we're talking about. So in the original example we had about 20 enemy ships across here. Each one of those is a separate instance, and the self here is talking about the particular instance. Okay, so if I save that now and I run it, we've got no errors, but it's not actually loading this at the moment. Alright, it's not been loaded at all because all we've done here is we've required the class. I need to put in something here that's going to display the enemy. Alright, so what I'm going to do first is I'm going to create an array which is going to be hold all the enemies. This is going to be very similar to what we did with the balloons example. Alright, and now I've got two for loops here. The first for loop is getting passed across as the x coordinates. Alright, so actually I'll get rid of that for now, just so you can see what's going to happen. And I'll get rid of that one. Alright, so all we're doing here is we're going through. The first time it goes through, there'll be no enemies inside the all enemies table. So it'll go hash all enemies. That works out how many are in the table, so that'll come back with 0 plus 1 equals 1. So all enemies 1. The first enemy is going to load this enemies new, which goes over here, and that creates the class, assigns it to the meta table. Alright, the next thing we're going to do is we're going to say that all enemies, number of all enemies, which is now 1 because I've already assigned one then, init. So all enemies 1, init. So the all enemies 1 instance, initialize that with the values I and j. The first time it runs through, I will equal 1 and j will equal 1. That'll get passed over here to xlock and ylock. We're not placing it yet, but we'll get back to that. And then we're starting it. As of yet, there's nothing down here that we're starting, but we'll get to there. So if I save that now and load it, you can see we've got a robot or an enemy. There's actually more than one there, but they're all in the same place. We've passed across I and J, but over here we're not doing anything with those values, which is the next thing we're going to do. So usually I like to set the reference point for the robot at center. Alright, display.center reference point. That means that when I pass across these values, it's talking about the center of the object, not the top left or the bottom right. Alright, now we need to do something with the X lock and Y lock we're passing over. So I'm going to access the X value of the image variable and set that to equal to X lock, which is coming over here, and the Y value is going to equal Y lock. So if I save that now and run it, alright, you can see, because we sent it to center, the first time it's run, I equals 1 and J equals 1. So we're saying the first one's going to be at 1, 1, which is, now we've set it to center reference point, is off the screen because it's talking about the middle of it. So we need to do something with those values. So if I say the first time it runs through times, say 100, and I save that and I'll load that again. Alright, you can see that they're going across the screen. How many have we got here? 1, 2, 3, 4, 5, 6, 7. So there's 7 of them there, and we're calling 7. That's probably pretty good, but we need to bring them down because there's 4 rows of them we have to display. So you just play around with these figures until you get something you like. I'll save that. I'll reload that. There's 4 of them. There we go. We've got all the enemies. Are they spaced out as much as we want? Maybe we want to space them out a little bit more. Alright, that's good spacing. And I probably want to drop it down a bit from the top of the screen because we're going to want to add a score or a title or something at the top there. So if I do that, alright, that's probably pretty good. Alright, so that's all I'm going to have to do for the enemies class. That's all I want to do. So to recap, sorry, I'm requiring the class into enemies here. For each instance, it goes through, it makes a new instance. It initializes that by passing over these values, which go into here, and then it starts it. At the moment, there's nothing in start, which is probably the next thing we should do, because we want to have it actually move. Now, how do we move things across the screen? You might remember from the scrolling one you had, there was a runtime event listener. We can do that here as well. So in here, alright, so let's step through this. Runtime, that means it happens every frame. Every frame, oh, it's going to happen, sorry, it's not every frame, it's applied to the engine, the game engine. It's not applied to a particular object, it's applied to a game engine. What are we doing? On enter frame. So that means it's going to happen every frame. Alright, it's self. Now, you might be used to, in previous ones, you might have had an actual name of a function here. Maybe I could call it move enemy. Alright, enemy. Alright, that would be fine. Then I could make a new function up here called move enemy and move it across the screen. However, I'm going to use self. The reason we're using self is because if I call this move enemy, alright, when we want to remove the listener, Lua gets a little bit confused. Because it's an instance, this is slightly technical, but because it's an instance, if I then later on say, instead of remove, if I later on say remove event listener, it actually thinks it's talking about a different event listener, even though it's got the same name. Slightly technical. All you really need to know is if I call it that, it makes it harder to remove it. If I'm calling it self, Lou is smart enough to know that we're talking about this this event listener. But we need to now create a function. We can't call the function self, so what do we call the function? Well, in this case, we're going to create a function called enterFrame. Alright, the name of the function will be the same as the event we're listening for. If it was a touch event, then we'd call the function enterFrame. Touch, sorry. If it was a tap event, then the function would be called tap. You'd still say self here. Alright, so it's a method of enemies. Notice that we're using a dot here. By using a dot, it means that we can access the self in event. If we make it a method and put a colon there, semicolon there, colon, alright, it will only pass across event. I'm not actually 100% sure for the reason behind that, but that's what happens. So we're using a dot. Alright, so what do we want to do on each frame? Alright, so we want to move it across the screen. That's simple. So I'm going to say self.image.x equals self.image.x plus 1. So just every time a new frame is loaded, it's going to load this, and that's going to move it across the screen. Let's check if that works. There you go. It's moving across the screen. We run into a slight problem. As you can see, it's running off the screen. Now, how are we going to fix that? Alright, we're going to fix that by putting in some boundaries around the screen so that we can detect the collision. Alright, now we've done that before, you might remember, in the balloon one. We put a wall around it. Okay, so we'll do that now. Alright, to do this, I'm basically going to copy the code out of that balloon one. Alright, we're going to put it into our main storyboard. Later on, we're going to move this into a class of its own. But for now, that'll work. If I save that and I load that, no errors, and you can see there's a slight line around there. The wall's there. Alright, but it's not doing anything yet because we haven't set up any collisions. Alright, just looking at the code. Actually, that should be down there. Alright, looking at the code, we've got a left wall. We've been through that before. We've got a left wall, so that goes from the top left down to the bottom left. And we're giving that a name of left wall. This name is going to be used later on so that we know which wall the alien is hitting. Alright, and then down here we're defining them as physics bodies. The only thing we're telling them is there's a bit of a bounce. We don't really even need that, to be honest. And they're all static bodies. They don't move. They're not doing anything. They're just there just to detect collisions. Alright, back over in our enemy, we now need to detect when it collides with a physical body. Alright, so how do we do that? Well, yet again, we go down to our start. That's where we're starting any listeners or anything. And we can type in. So self.image, we're talking about the image, which is this little guy here. The image of this instance. We're checking for collision. And we're using the self keyword again, just because it makes it easier to remove the class. Alright, so because we're using self, that means we're going to use the function name collision. Alright, so we want to make a function. Let's just make it here, same as we did before. Put the end in. Alright, so what do we want to happen when there's a collision? Alright, so it's heading right. When it's a collision, we want it to head back left. We could just try and say, if I copy that line here, alright, and paste that in there, and just make it a minus instead. Save that, load that, see what happens. Oh, nothing's happening yet, so something's not right. Self.image. I just want to put a print statement in there and see if it's actually getting to here. Prints are very useful when you're trying to check what's happening to your code. Save that. I reload it. It's not actually getting there. Oh, I know why. Quite a simple one too. I never told Corona that my image was a physics body. So what I need to do now is define my little guy as a physics body. That's a definition. We're just going to initialize, so I'll put it in there. Alright, save that, reload that. Alright, as you can see, that doesn't really help. They just all push up against the right side there. And eventually it'll probably spit out an error. They're basically all just going to try and line up as far to the right as they can, which is not fantastic. So obviously just subtracting one from it doesn't really help. What do we need to do? Because basically that would move one of it, then it would go up here and move right again, come down here, move left, go up here and move right again. Alright, we need to be able to control which direction it's moving. So what I'm going to do now is make a new attribute called movement and give that the value of 1. Alright, so every instance will have a movement attribute and it'll start off with 1. Okay, so down here in the enter frame I'm going to tell it to move whatever movement is. So if I save that, reload that, still doing the same thing, that's fine. Alright, now down in your collision, alright, I'm going to then tell self.movement equals self.movement times -1. Alright, so when it's heading to the right, it's a 1. If I times -1 by -1, it becomes -1. So then it'll be it'll say X position plus -1, so it'll go back in the other direction. Let's see what happens there. It's the wall. Slowly trying to go back, but it's less than perfect. Well, these guys finally did it. Some strange effects going on. Alright, this is kind of happening for 2 separate reasons. The first one is when it hits the wall, it's actually registering multiple collisions. It's kind of a little bit of a problem in Lua. So we have to make sure it's only getting 1 collision. And another problem is it's only the ones who are hitting the wall who are getting the message. We need to make some sort of system here that will let all the other ones know what's happening. What I mean by that is, alright, we've got there is 21 aliens here. They're all happily moving along to the right, and they're approaching the end of the wall here, and they get closer. Alright, now what's happening at the moment is, well, as I said, 2 things. They're getting stuck on the wall because they're going back and forth because they're registering multiple collisions. So basically, in our code there, it means it's getting times by self.movement, which is, oh no, sorry, here it's getting times by -1 over and over and over again, which just makes it jitter. That's one problem. Another problem that's happening is it's only these ones that are colliding. So if that happens, even if we sort that out, these are going to start heading back in this direction, but all of these will keep moving in that direction, and eventually they'll hit each other and force these back into the wall, and they'll all start sandwiching up again. So we've got to fix that problem. The best way we can do that is we need to put in So what we want to happen is when these guys get close to the wall, so these guys are moving along, they're going to touch the wall. We want one or all of them, as it'll be. We want these guys to shout out, hey, 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 we've hit the wall, we've hit the wall, everybody turn around. And that'll cause all of these guys to turn around as well. We can't just change the settings inside one instance because it is only one instance. That won't affect everything else. That's the good and bad thing about object-oriented programming. Each instance will act independently. So we need to have these guys, when they hit this wall, to be shouting out, saying, talking to these guys, hey, turn around, we've hit the right wall. Or alternatively, when we get to over here, we want the guys on the other side. We want the guys on the other side here to shout out, hey, we've hit this wall, turn around, turn around. This has the added advantage that once these guys have disappeared, it'll actually go further in this direction until those guys hit the wall, and then these guys will take over the role of being the shouters, and they'll shout out. It would only require one guy to hit two, so if there's only one guy here, he'll still tell the rest of them we've hit the wall, and all of them will turn around and move back in this direction. Alright, so how do we achieve that? Alright, we're going to use something called, my program's still running in the background. We're going to use something called a dispatch event. First thing we want to do is we want to detect if it's the right wall or the left wall. Alright, that's going to make it useful for us to know which way they're going to go. Alright, so you look over here, we called this one a left wall and this one a right wall. It's quite useful. Alright, so in here, we want to say if event dot other dot name equals right wall, then dispatch this message. Alright, what's that going to even look like? I'll show you right now. Alright, here it is here. So we're creating a message, we're bundling up a message, and in that message we're saying the name of the message is hit left wall event. Could be anything we want. The important thing here is that this word here and this word is the same. Don't have to be message. It could be Bob and Bob. Doesn't matter. And we're using the word name here. That's important because that's what it's going to detect. The name could be anything you like. Alright, and remember I said that having the scene present in the class was important. This is the main reason. We can now attach this event listener to the scene dispatch event to the scene. Alright, all of these enemies are listening to the scene because they're all instances of the enemy class which is in the scene. Okay, so they're gonna he's now going to dispatch an event. So in my little example I've got over here, or I've currently got, is these guys are happily dispatching their messages. They're going to put out their message. So they're going to say, hey, we've hit the wall, but these guys are deaf at the moment, and they're going to keep moving over to the right further and further and further. So we need to have these guys listening for that. So how do we listen for an event? Same way we've listened to events up until now. Alright, we're going to add a event listener. Where do event listeners go? Same where as place they've always gone. They're going to go in the start. So down here, Same as we've done before. On the scene, we're adding an event listener. We're listening for hit right wall event. This has got to be the same as that, and it's going to call self. So the same as we did before, we're going to create a new function which is going to be called hit right wall. Same as we did before, so let's put that down below it. Alright, so whenever this guy over here shouts out, these guys are going to hear it, or actually everyone will hear it, and it's going to load this function down here. What do we want this function to do? Alright, now we've got to handle the other problem we had. The other problem we had is it's calling multiple times and bouncing off the wall. So I'm going to add a new attribute in here called self.writeHit. Alright, and that's going to equal 0. Alright, so we only want it to load once. So in my thing, I'm going to check if that equals 1. So I'm going to check if self.writeHit equals 1. Then I'm going to do something. What am I going to do? Well, I'm going to reverse its direction. We already had that command in there. Alright, and that's almost there. One thing it's not doing is we're not incrementing self.hit. Alright, where do we want to increment that? Alright, if we put it at the top there. Alright, so when it hits this, it'll increment self.hit.1, which then it'll say, does self.hit equal 1? Self.writeHit equal 1? Yeah, then reverse it. It'll then try and call it again, but this time self.writeHit will equal 2, so it won't load it again. So if I save that now, reload that there. Alright, we're still not working. Alright, there we go. The reason that's happening here is because I'm dispatching hit left wall, but I'm listening to hit right wall. They have to be the same. Alright, so if I save that and run it now, it hits the wall. Oh, good. Going back in the other direction. Of course, it's not going to stop there properly because we need to put in a listener for that side there. I'm going to get rid of that I am here thing. Alright, so we need to make another listener. We'll just copy that one. We'll get that one. We're going to call this one hit left wall. We need to copy this there. We'll make that an else if equals left wall hit left wall, and we need to duplicate this function. Alright, this time the function needs to be called hit left wall. Alright, we need to change this to left wall hit left wall left wall. We need to define this up in our initializer up here. So A equals 0. Save that. Oops. Run that. Hits the right wall. It goes back. Gets to there. Goes back. Gets to there. Oh, we got a problem again. Alright, that's an easy one to fix. The reason we've got a problem again is because down here, self-right wall it's never going to equal 0 again, so it's never going to equal 1 again. So we need to reset this. We should reset that down here in the left wall 1. So we'll say that equals 0, and we'll reset the left wall. Oops, reset the left wall 1 and the right wall. We reload that. Oh, we got an error. Double equals. Oh, we don't equal. Ooh. I'll make that equal 0 as well. Alright, so we're going right, we're going left, the right one, yes, and it's just going to bounce back and forward until it is no longer needed. Now in the Space Invader game, it drops down. Alright, it does this for a while, then drops down. So we want it to drop down. That'll just keep going forever, which is not very exciting for the player. The way I'm going to do that is I'm going to make a new function which is just going to check how many times it's hit the wall. I'll put that in both of these. Okay, so I'm going to make a new local function. We'll just make it above those two. Alright, we'll end that. Okay, now if that we want to create a new variable that'll keep count of whether it's hit the walls or not. We'll just call that number of wall hits. And we'll have that is equaling 0. So I'm going to make it when it's hit the wall 4 times, it drops down by a certain amount. So down here in the num checks, we're going to first thing we're going to do is increment the number of wall hits. So each time it gets there, it gets incremented. Alright, then we're going to check if it equals a certain number. Alright, now if it equals 4, what do we want to do? What we want to do is we want it to drop down by a certain amount. So dot y, so it's going to drop down by 30. If I run that, oh, cannot translate an object before collision is resolved. So what's happening here is I'm trying to drop it down, but it's trying to drop down at the same time as it's colliding, and Corona doesn't like that. So we're going to do a little bit of a workaround. So the workaround I found on the net. Alright, so what we're doing there is we're saying timer performs the delay. That's just a delay of 1 millisecond, so you'll never notice it. What's it going to do after that 1 millisecond? It's going to run this function which moves it down by 30. So it's going to wait 1 millisecond, move it down by 30, and this is only going to happen once. So if we do that, run it now. Oh, we're only doing it once. Now the obvious reason for that is we're never resetting it. Alright, so we want to say when it does equal 4 that we're going to reset it back down to 0 again. Alright, so inside here, save that there, reload it. Alright, that's happening every time. Why is that happening? Alright, that's happening every time because same problem we had before. The reason we did this check here is because this is getting called multiple times, sort of a problem with Corona. So we need to move this inside this if statement. We need to move this inside this if statement. Now we'll try it. 1, 2, 3, should drop on this one, drop. And the same thing should keep happening over and over again until it gets to the bottom of the screen. Alright, that's the end of the enemies class, really. We're going to have to come back to the enemy class later to add some collisions for when we shoot it, but you've got the basic functionality there.